So why don't we first talk about what Docker is? So everyone's been using Docker and Sailbot Workspace. Like, what's your perspective of what Docker is right now? Jamie, go ahead.
I'd say it's an application that you use to make software run independently of other software on your system. And that way you can make sure that everyone working on your project is working in the same software environment.
Okay, yeah. How about one of the new members? Someone from this corner. What do you think Docker is? Or what's your understanding of Docker right now? Code running on one environment. Yes, it can run the same way on the other environment. Yeah, those are all correct answers. If you go to the setup page of Sailbot Workspace, I also put a one-sentence summary of what it is. Docker is a platform that uses OS level virtualization to develop, ship, and run applications. So I guess it's more official terms, but if I were to put it into my own words, Docker allows you to wrap all the dependencies with your software all together so that you can run your software no matter where you are. And that is why we use it in Sailbot Workspace. First of all, we all have different computers, right? So some of us have Windows computers, some have Mac. Some of us are running different architectures on their CPUs. So Intel and AMD, they use the x86 instruction set, whereas the newer MacBooks, they use ARM instruction set. So Docker handles all of that for us so that we don't have to worry about it as software developers. So not only do we use it to develop our software, we also use it to run our software. We're developing it on our own personal computers, but we'll be deploying it on the computer on the boat. And the computer that we're using on the boat is called the Raspberry Pi. And that's also an ARM processor, which supports running Docker images.
Are you recording this?
Yes. Yeah. And one more place that we're using it, not just on our personal computers, on the boat itself, but also to run our automated test on GitHub. So if you go to Sailbot Workspace, you'll probably notice that there's this green check mark over here, and all of these are running different tests, checking for different things. And the reason why it's able to run is that it's running inside our Docker images. So with that out of the way, let's get more into what are the key components of Docker. There's kind of three main components of Docker. There's images, containers, and volumes. So let's go over images first. A Docker image, you can think of it as the definition of the container that you're about to run. Okay, wait, let me search this out. Let's see if we can find a better definition.
Class, for example, template for an object. An object is an instance of a class. So you can think of images versus containers as a container is an instance of an image, but the image actually is someplace with the container.
Yeah, that's a good definition. So the Docker image is a definition of the dependencies that you'll be running, whereas a container is an instance of you actually running those dependencies and your software. And the last component is a volume, a Docker volume, which is a bit difficult to explain right now. I will do a live demo to see kind of like how this all works together. Let's go over image first. So typically images are stored on a website called Docker Hub. So here you can browse all available images. There's images for all the different popular software. Why they publish this is that so we can run them as easy as possible too. It's just as simple as pulling these images and running them in the container. The one that we're using in Sailbot Workspace is Ubuntu. So even though we're running like Windows or Mac or whatever, we can still run Ubuntu on top of that and have Ubuntu commands. So right now, if you go to the Ubuntu page, you'll see that there's a bunch of different tags. Now, tags are like the versions of the image. These are different versions of Ubuntu. If you know Ubuntu, they have like an animal name as well as like a numeric name, which follows a year. So 22.04 is released in April of 2022. And you can search up all the different tags over here. Usually the latest tag is populated automatically. Whatever has been pushed most recently, you can just get the latest one with the latest tag. But for example, if we go to the one that we're using in Sailbot Workspace is 22.04, and it will give you a command to be able to download that image onto your own computer. If you're running Windows, Docker is available through Docker Desktop. If you want to run CLI commands, small caveat is you can't do it in PowerShell. Or maybe you can, but it just doesn't work very well. So what I would recommend you do is do it in Ubuntu. So if you like, as part of setting up Sailbot Workspace, you would have downloaded Ubuntu. So you can just open this app. I already have it open over here. You can run the Docker commands over here. I just copied that command as here, Docker pull image name as well as image tag. Right now it's downloading that image. The command to list all the images is docker image ls. I have a lot of images, but yes, I can grep for it. So you can see I have a bunch of different Ubuntu like versions downloaded on my computer, but the one that I just downloaded was 22.04. Now that I have an image, what I can do is run that image in a container or start a container to run that image. And you do that through the docker run command. So for instance, if I want to run the Ubuntu 22.04 image, I would do docker run Ubuntu 22.04. But as you can see, that didn't really do anything. So if you want it to open in a terminal, you can use something called the IT arguments. So this opens Ubuntu in an interactive terminal. So now this opens up a terminal in the instance of that image. So I can type in Ubuntu commands just like you could like on your computer. Now that for containers, what you would use is the docker ps command. So to check your running containers, you do docker ps. You can see we're running this certain image. It gave it an ID, and the command that it ran was the bash command. So now we're in the bash shell of this image. If you want to see the images that aren't currently running, for example, if I exit out of this image, it'll immediately stop it. And if I do docker ps, that won't return anything because there's no running images. If you want to see all images, even the stopped ones, you do docker-a. I will again grep for Ubuntu. It seems like I have two different containers because remember, I ran the docker run command twice. I did it with the interactive terminal and without any arguments. But each time you run it, it will create a new instance of that image. If you don't want to create a new image instance and you just want to run an image that you already created before, you can copy the commit hash over here. So if I want to run this command or this container, I just copy it. And I think it's docker start. Might have to give interactive terminal as well. But if you forget, you can always use the -- help in all these Docker commands. Okay, so not IT, just -I. Great. So now we're back inside that image. Now, sometimes you don't want to like keep this image around. If you already created it, you can use the docker rm command to remove it. So now when I try to start it, it's going to say can't find the container. The other option is when you're running the container, you can choose to delete it right away after you stop it. So for that, you would use the --rm tag when you're running it. So Docker run interactive container, but also remove that container when we're done with it. So that's one way to use Docker images in the interactive terminal, and you can type commands into that. But the other way is when you're deploying applications, you don't want people to like, the purpose is not for software developers to like play around with the terminal. It's just to run the program. So for that, I will show you a minimal Docker example that I set up in Python. So I just have one simple Python file. It imports NumPy and it prints hello world as well as a NumPy array. So I'm using the NumPy library to create this array. Now, if I run that on my native operating system, or rather in my Ubuntu terminal, Python, okay, so it's in this terminal, Python 3 main.py, what I'll get is I don't have NumPy installed, right? So one way is I could install that on my computer, or I could just create a Docker image to like just wrap all the dependencies into one and run it there. So how you would, okay, let me go back to, I don't want to get ahead of myself right now. Covered Docker images, containers. Yeah, okay, so those were all the terminal commands, right? But if you're running Windows or Mac, you'll have Docker Desktop installed, and that's the other way to manage images and containers and volumes. So I'll show you what that looks like. There's a, on the left-hand side, you can see there's a tab for each of them. And this shows you all your containers that you have. If you, oh yeah, go ahead.
Sorry, what was the volume again?
We haven't covered that yet.
Oh, okay,
yeah.
good.
So we're just covering containers and images so far. You see that one of the Ubuntu 22.04 containers that I ran is now stopped. If I want to delete it, I guess it's much more intuitive to do it in Docker Desktop if you have that available.
So
yeah.
Sorry, so is Docker Desktop basically a GUI that's doing the same thing as you can do in the terminal?
Yeah, exactly. No, actually you can start stop containers in Docker Desktop.
So it's a GUI that does most of what you do.
I use it, so
I haven't tried this, by I guess you can run a container this way and you can specify different arguments. You can specify volumes, which we will get into. But I find this more intuitive in the command line, to be honest. Okay, so that's Docker Desktop. Yeah, so tying that back into Sailbot Workspace. Sailbot Workspace runs in a Docker container, but to have a Docker container, we need an image, right? And all these images, instead of Docker Hub, we're storing them in the repository itself. If you go to the homepage of Sailbot Workspace, you can see we have a bunch of different packages. That's what GitHub calls their images. Maybe it's copyrighted by Docker, I don't know. So these are where our images are pushed. And when you run inside the dev container, you show the logs, you'll see that VS Code is actually running all these Docker commands for you. Doing a bunch of different checks. Doing Docker PS. Remember, we covered that. That's how you list the containers. You have -A is a list of the closed containers. Yep. These are the images. So we push our own custom images, which I'll go over later, like how to create images yourself. But right now we're just focusing on how to run images. I get this annoying bug with Sailbot Workspace sometimes where it doesn't open first time. So I'll try again. Okay, yeah, it worked this time. Great stuff. So right now, notice that we're in the dev container. I guess I'll just show this in Docker desktop. You can see that we're running some containers. Sailbot Workspace is running in this container. But in addition to the main container, we have a couple additional containers that we use. The reason, so we have containers for the doc site as well as the website, and we want to abstract these away from our main development environment because they'll be running in different places. So everything in like this running in Sailbot Workspace should be able to be run on the Raspberry Pi on the boat, whereas the website will be deployed on another server. So we kind of want to separate the dependencies of those different softwares. So how you would run the website, this will be pushed to Sailbot Workspace soon, but how you would run it is if you go to the dev-container.json file, there's some commented out Docker-compose files. There's one for the website, and if you uncomment this and save the file, notify you that you need to rebuild the container. So what this will do is when it's rebuilding the container, it will detect that you also want to run the website, and it will run the website container in addition to that. So now you can see, in addition to Sailbot Workspace and MongoDB, our database, we're also running the website. Yep. Yes. But the way they communicate, the way we can access it, like a container is like isolated environment, right? But the way we can access that is through ports, like a website. So for the website container, we forward the port 3005. So that's how we can open it on our local machine.
Docker, other things, Kubernetes. Kubernetes is something called container. If it has managing clusters, which is a separate topic, but you see that that's what.
Yeah, so now we're running the website, which is actually running in this container. We're just forwarding the port to our local machine so we can open it on localhost. The one other thing that you have to know about using containers in Sailbot Workspace is sometimes we update our images if we want to add a dependency. So I'll do a live demo of that right now. I created this PR. And as part of that, I'm changing the base image that we're using. So the image is the same, but I updated the version. Remember, the tag is the version of the image. So I built a new image, changed the tag. Now, when I merge this in, you will get a notification, or sometimes you'll be able to see this. Get out of here. If you pull it. Okay, you can't see it from VS Code, but if you open a terminal, Sailbot Workspace, you get fetch, get status. Where's this? Just try get pull. Update pre-base image. Okay, so for some reason, it already automatically pulled that for me. Did not have to change anything. So again, when you do that, you might get the notification that you have to rebuild the dev container. So if you don't get that notification, you can also run the VS Code command rebuild container. So that will use a new image to rebuild the container that you're working in so that you have the new dependencies so that you can run our software. I won't demonstrate that right now because I already rebuilt it before. Okay, so any questions so far about images, containers, Docker Desktop, Sailbot Workspace? We'll cover volumes next. A little bit, but I can go over that again. So in Sailbot Workspace, we have definitions for our images that have all our dependencies required to run our software. But as we're developing our software, we might need new dependencies or new packages to install. If that's the case, we'll have to add them to our images, rebuild the image, and then push that to Sailbot Workspace. So for you to get those changes to our development environment, you'd have to rebuild the container. Does that make sense?
So that's done through the Sailbot Workspace GitHub repo.
Yes. Yeah. So now let's get into my minimal example that I have over here. Oh yeah, go ahead. Not really. You just have to check inside the container. Unless you specify it in your Docker file. But if you do, for example, just like pip install NumPy, it will fetch the latest version of NumPy at the moment it was being built. Mm-hmm. Yes. Yeah.
So then if you're rebuilding, it won't get installed.
Sometimes it will detect it, sometimes it won't. Yeah. But I'll get more into that in this example. Any other questions? Go ahead.
I don't know if it's because you can defer this to later if you want to answer it later, but how does Docker compare to Python virtual environments?
So Python virtual environments is good for Python because you can download any Python dependency that you want in an isolated environment. I guess you're talking about like env or conda, right?
Yeah.
But sometimes when you're like us, we're working across many different languages. Like Python environments only manages Python. It can't manage other languages or OS level dependencies, such as we might want to download packages on Ubuntu. That's not like specific to a language. It's just part of these operating system. So in that case, that's why we use Docker.
Share.
Yes, it will be a bit harder to manage. Yeah. Any other questions? Yeah, Chris?
Say like I mean, Docker can do
it. Yes, technically it's possible. Like you can do anything that you could in an operating system in a Docker container, right? So you can create a virtual environment if you wanted to. But again, yeah, it's probably redundant. You're right. Unless you wanted to have multiple virtual environments to run to use in different softwares. Yeah. So back to the minimal example, all I want to do is import NumPy, but NumPy is not available on my system. So now I'm going to create a Docker image that installs NumPy for me so that I can run it in the Docker container. So how images are defined are in files called Dockerfiles. So this is what I have open in the middle over here, a Dockerfile. So the first line of any Docker file is the base image that you're starting from. So here that is Ubuntu 20. These are some other commands that you might run to in a Docker container. env sets an environment variable. Run allows you to run like a terminal command. Copy allows you to copy files from like your computer into the container. And CMD allows you to run a command, not right now, but when you're starting the container, like the instance of that image. So I'll demonstrate what that looks like right now. So right now in this image, what I'm doing is starting from Ubuntu 20.04, I am installing pip from apt. So apt is the package manager for Ubuntu. Like we were talking about before, this is a OS level dependency. And then I'm using pip, which is a package manager for Python, to install NumPy. And small thing is I'm also making a directory called app. And this last part is I want to run my main.py when I start the container. First thing that I do here now is to build an image. So I would use the docker build command and you specify the context. So right now, this Docker file is in the current directory over here. So I would do docker build period, which is the current directory, and then I'll give it a name. So I'll call this image Docker example. So right now you can see it's running through the commands in my Docker file. Right now it's installing pip. Starting from Ubuntu 20.04. Hopefully this doesn't take too long. Yep. Yes, so Ubuntu comes with Python installed. So we're using the one that's pre-installed in Ubuntu. But pip is not installed. So I guess I can talk a little bit about apt, which is a package manager for Ubuntu. The first command is you want to update its packages that has available. So it checks if there's any updates to the packages that it knows. And then I'm installing Python pip. And I'm just using backslashes, so it goes on multiple lines. But this is the same command over here. And then I am cleaning up like the cache that it used to download pip. So the reason why is every command in a Docker file is, you can think of it as a layer in the image. So this allows like to do what Sean was talking about earlier about caching different parts of the Docker file. So right now I've completely built this image, right? Now, if I want to make a change to this file, let's say I want to also install pandas. I save that file and then I try to rebuild it. Docker is smart. It knows we didn't change anything over here.
You need to be free.
Yes, I do. Good catch. It knows nothing changed in the parts above. So do you see it says like these commands are cached? So now when I rebuild it, it starts from the change. Pip install pandas. So back to the reason why we remove like any files that we don't need is to keep the image as small as possible and that layer as small as possible. Yeah. This is how you name the image. So it stands for tag. So if we go back to Docker image ls, which lists all your images, and you grep for Docker example, which is what I named it, you can see this is what I just built, right? You can already see this is like a couple hundred megabytes. So these do get quite large. I think our final one in Sailbot Workspace is around 3.5 gigs. Okay, so now I built this image. Now I want to run the image. Anyone remember the command to run an image? Good one. Yes, Docker run. So now, okay, I want to run image Docker example. But oh no, I can't find the file. So there's a couple ways that you can get the file that you developed on your own computer into the container. The first way is through the copy command. So this does exactly what you think it does. It just copies the file. The first argument is like a directory or a file on your operating system, like your main computer. And then that will copy it into a directory that you specify as the second argument in the container. So this is a path on your computer. This is a path in the container. So now I uncommented that. So we'll copy main.py from my computer into the container, and I will rebuild the container. It ran this additional command, copy main.py app. So now when I rerun, it should work. Now I print hello world and the NumPy array. Now there's another way to do this. Instead of manually copying this file, what if you want to like make changes to the file while you're running the container? For that, you would use Docker volumes. So Docker volume is like a mapping, like a constant mapping from your computer to the container. So these changes are always like synced to each other. Now this isn't specified in the Dockerfile. This is rather specified as a run argument. So I think I did this before. Yes. So now what I'm doing is I'm creating, let's go through all these arguments. Docker, we're running an image. First, let me rebuild without the main.py. And when I run it, now it doesn't work because main.py is not in the container. So now we're running it. We want to delete it right away after we're done running it. And we specify a volume. In the same way, we give it a path in your main computer, separated by a colon, and then a path in the Docker image or in the Docker container. So right now we're copying main.py, which is in the current directory. That's what pwd does, print working directory, into /app/main.py, which if you remember, the command that we're running as we start the image is python3 /app/main.py. So that's where we want the file to be. And the last argument is just the name of the image that you want to run. So now when I run it, it works. Yay. So that's about all you need to know for Dockerfiles, but there's one additional level that was, I guess, semi-recently created called Docker-compose. We also use this in Sailbot Workspace. But this is a way of specifying your run configuration like that you would normally put as arguments in your run command, like in a file, so that you don't have to like remember all these command line arguments all the time. Another common command line argument yeah, -p allows you to forward a port from the container to your main computer, which is what Devin talked about earlier about forwarding a port from the website's container into our main computer. So you can specify all of that in the Docker Compose file. Here is a very, very simple Docker Compose file. It's a YAML file. You specify the version of Docker Compose and you give it a bunch of services. So services are the containers that you want to run. So this is, I only have one container that I want to run and I call it Docker Compose example. So sometimes you can specify like directly what image you want. I forget the exact syntax, but you can do something like from Ubuntu 2.04. But right now, instead of fetching an image, I want to use my custom image that I developed in the Dockerfile. So I give it the build argument, set the context to the current directory, and then I give the Dockerfile to be the name of the Dockerfile. And then I specify the volumes that I want. So remember in a Docker run command, this is what we did. Current directory main.py to /app/main.py. Right now, I'm just dealing with the directories themselves. So I'm mapping the current directory to /app in the container. Now, how you would run a Docker Compose command is Docker Compose up. And this will automatically detect that we want to use the docker-compose.yml. So now you can see when I run the Docker Compose command, I didn't have to specify like the arguments for the volume or anything. It just ran the image.
So the up is saying use the volume created in the previous.
Up just means to run the image.
Oh,
yeah. Like to start the image is defined in the Docker Compose file. So now it's running. Should be able to see. Okay, I guess it stopped right away. But usually if the container keeps running, you can also do Docker Compose down to take down the containers, to stop the containers and to remove them. Any questions about volumes, Docker files, or Docker Compose files?
I have a question.
All right, let's move on to where these are defined in Sailbot Workspace. These are defined in the dev container directory. Right now we're in the dev container directory. We have a separate directory for each image. I'll just open one image as an example. We have the base dev image. So this is a Docker file that creates our base, local base, and dev images all in one file. You can see at the very beginning, we're starting from a version of Ubuntu. And then as we go on, we're just like installing all our dependencies.
just a few.
Yes. Yeah, a lot of stuff to get it working. But one thing that I want to highlight from this file is you can build multiple images from one Docker file. As you can see, like I specified from again. So usually from is specified at the top of the file, right? As the base image. But really you can use it wherever you want to define like a new image. So there's a bunch of different I guess how I could describe it is you're naming the layer at that moment. So as we go down the file, we're adding dependencies, and each of these commands is a layer in that image. So once we get to this layer, we're going to name this layer. Actually, this layer is called OMPL Builder. Yep. And you can do fancy stuff like instead of copying from your main computer, you can copy from a different image. But this is pretty advanced. We don't have to get too far into this. What's important is just you know where these are defined. So this is where the base dev image is. Yep. Yeah. Starting from that image. There is a list on the doc site of all the images that we have. So we have base, local base, and dev. This is all built in the base dev Dockerfile. And if you want, you can look at the other images we have. Like we have an image to create the docs container as well as the website container. And they all have different purposes. Mm-hmm. Yeah, so I'm naming that as fixed certificates. So I can specify instead of this, I can specify fixed certificates later on. So reading from top to bottom, we're starting from Ubuntu and we're naming the image fixed certificates. Into this image, we're installing these dependencies. Now we're creating a new image or a new layer on that image. We're starting from fixed certificates, which if you remember is everything here. And then we're installing these dependencies. Does that make sense? Yes, yes. But the reason why I named this is we can do more complex stuff later on in the file. So here, I'm also starting from fixed certificates. So in this image, I don't want any of this stuff. I just want the top part, right? So like you can think of fixed certificates as an image here, and then from here, we're creating two separate images, kind of like a tree. This one is called ROS Prebase, and the other one is called OMPL Builder. Yes. Okay, we went over where the images are defined. Any questions about that? Now let's say we want to update an image. Let's say we want to add like a Python package. We just look for in this file where we install Python packages using pip3 command, which is the pip package manager. For instance, here we're installing a bunch of packages. Yeah. So let's say we want to install NumPy here. I'll just add a line. In addition to all these packages, I also want to install NumPy. I can save this file and then I can rebuild it like I showed with the minimal example. Okay, here comes the fun part, debugging. So sometimes things don't go as you think. Docker can crash, or like when I showed earlier, like it didn't open the first time. just wanted to go over some basic debugging steps you can try. So kind of the first step is like when you close VS Code, it does not delete your container, like the instance that you're running. So you can see it stopped, but it's still there. So maybe there's something wrong with your particular container. So you could try deleting that. Sailbot Workspace. Yeah, like this. So when you delete the container and reopen Sailbot Workspace, it'll detect, oh, there's no existing container. We have to regenerate one for the image. Another thing that you can try is deleting the volumes that are being used. Okay, I didn't go over this yet, but Sailbot Workspace uses a number of different volumes. We have one for MongoDB. Oh yeah, okay. So the other purpose of volumes is so that we can persist data across containers. For instance, like MongoDB, let's say we populate the database with something, but something goes wrong with the container. Instead of just like deleting everything and starting from scratch, we can just rebuild the image using a different container, and then just import like the contents of the database into that image. So you don't have to start from scratch. We can keep the contents of the database, but nothing around it, like all the dependencies that are required to run it. And we do the same thing for like the ROS log or bash history, so that when you like have to rebuild like a new container, you can still access the logs that you generated in past containers, or access your like bash command history.
Thanks for that. I like how you love command history.
Yes. Let's see. Give update images debugging. The other thing is, once you start like building a lot of images, like even if you aren't like developing Docker images, Sailbot Workspace is updated frequently. So when you update Sailbot Workspace, sometimes you have to rebuild the image. You'll start to use a lot of space on your computer. I have this program called WizTree, which allows me to see like how much space it's taking up. So we go to users. This is my user account. These are where Docker like stores its files, and right now it's at 75 gigabytes, which is pretty large. And the bad thing is on Windows, it does not automatically shrink this. It can only get bigger. So if you're fine with this size, but you don't want to expand more, you can just try deleting your like build cache. I think you can do that with Docker system prune, right? They're prune. System prune. Docker system prune. There it is. So this will remove your build cache. If you specify -A, it will also remove like the images that you aren't using anymore. So if you go like back into images, you can see a lot of these don't have names. And the reasons why they don't have names is because they're old images of a tag that has been replaced with something else. For instance, when I rebuilt dev containers using this image name, so if I add a dependency, it will still use this image name, and it will untag like the previous version. And now it's just unused, not doing anything, taking up your storage space. So yeah, you can delete those. You can see like of my active images, I'm only using 10 gigabytes, but in total, images that I download consist of 30 gigabytes, and maybe even more now. I don't know. Yeah. Any questions? Okay, so last thing that I would touch on is where Sailbot Workspace Docker images are used. We already talked about VS Code, but having everything in Docker allows us to run it like wherever we want, like I talked about. So one of these places is GitHub code spaces. So this allows you to run our software without installing it on your own computer. So this is a feature of GitHub where they will host and run the Docker images for you, and you can access it and play around with that, which is really nice. Especially if you don't have like the most powerful laptop on hand. And I've documented how to set this up in the setup, the last section of the setup doc. To GitHub code spaces, we use it, like I mentioned before, to run our automated tests through GitHub. That's called GitHub Actions. I'll show you an example file. So this is specified in the .github folder of Sailbot Workspace, workflows. But maybe you can see it better in our here. So you can see to run our images, we're using the docker-compose command that I showed you before. This time with a new argument -f, which stands for file. So in case you're not using like the docker-compose.yml file in your current directory, you can specify the path to it. And now I'm building it instead of starting it right away. Onboard computer, this is another part of the Raspberry Pi. This is still a work in progress. We may need to update in the future, but right now it is in dev container deployment. So we have a script that we can run, like we can clone this repository on the Raspberry Pi and run this script. And that should be good to start run our software on the Raspberry Pi. Sure. Yes, a lot of different variables here to add a lot of different run arguments, which is not ideal. I think we could move this to Docker Compose, but the main part is we're running the Docker run command, which is specified here, which is again specified over here. So this is the command that we're running. You don't have to set this up. Yeah, so actually one of the primary motivations for me going to the trouble of creating Sailbot Workspace was before in Ray's local pathfinding code base. It was really difficult to install all our dependencies. We had this really sketchy script that we could run. It would only work if you're in Ubuntu, and it takes like 8 hours to complete, and half the time it would fail. Yes, I got really. Yes, so that was the main block for new members. If they weren't like super technical, they wouldn't know how to dual boot Ubuntu. They couldn't get it working on their own computer. Now all of that is abstracted away. You can run Docker and VS Code on whatever operating system you want. So you have no excuse. Yes, do not do that. But I'm sure if you're smart enough to do that, you can figure out. And yeah, the last place, like I talked about, is the website will be running on a remote server, which we can access from anywhere. So I haven't really talked about deploying it much, but should probably talk about before the end of the term how we plan to deploy our Docker images or like our software onto this remote server. Okay, I think that's all that I wanted to talk about. Any last questions? Yep.
I was wondering, how often do you use Docker in personal projects? I'm wondering if I should, like, do you have one for like Capstone, or is it like every little thing you?
Yeah.
I don't know.
The thing, okay, so, yeah, do you have any thoughts on this, Devin?
For 20K, because there's like a lot set, like a lot behind the trouble installing, so I made a container. Okay. People who install nights, so like these a lot of different places.
Basically, you use it when it's harder to figure out how to install your software than to figure out how to use Docker. Yes. And for everyone, like if you're working on a project with a bunch of people, like if you're just working on a personal project, you can set it up once and forget it, and then that's fine. But if you're working collaboratively and want everyone to be working with the same set of dependencies, standardize everything, Docker is one way you can do that.
Like, so if you're dealing with the raw, like I tried like installing ROS on the laptop.
Yes, ROS is pretty different.
Something.
It supports Windows. ROS 2 does. But very finicky, yeah. Because we set it up, you don't have to deal with it. All right, any other questions? Okay, I think that's it. Thanks, everyone.
Base.
Okay, yeah. So each image, it adds different dependencies that are required. Let's just start at the dev image. The dev image has everything that's above, as well as our development only dependencies. So stuff that you're only required in Sailbot Workspace and it's not required to run our software on the Raspberry Pi. So the reason why we have different images is so we can minimize the size of the image or the complexity of the image, just really keeping it to the bare essentials into whatever platform is being run at the moment.
Like imagine if we had to run Freebase every time we wanted to add a dependency, it's install one. Yeah, also that like 8 hours.
Yeah, but now I did some optimizations. I think I got it working on GitHub. It takes about 3 hours, so not too bad.